Lars Wikman.
Last I heard it was Lars Wikman.
Thank you. Lars Wikman, right? Is that closer? Let me let you do it.
Lars Wikman.
Founder and writer of Underjord, an experimental programmer ranging from embedded nerves to LiveView front ends. Shares enthusiasm for the beam across writing, podcast videos, and live streams. Let's give it up for Lars.
It's been a heck of a conference. Is this the third time I'm up here? Okay. Thank you so much for having me. It's an absolute honor to be closing this out. Thank you so much to Bruce and Maggie for putting this conference on, having me as a guest. Like, round of applause for Bruce and Maggie. And nice work from Keithley, because we're going to cover a lot of the same topics, and I just generally think he does it better than I do, so that's going to be fun. I have a sponsor that I need to thank, because they actually paid my way over here. So, Tigris Data. They do object storage, and they have some cool ideas about how to innovate in that space, and I think you should check them out. I will also gratuitously kind of work them into the talk as an example later, so keep an eye out for that. And this is my team. This is Underjord. They're the best people I could possibly imagine working with, and we build software for companies. It's mostly functional software, and recently it's a lot of nerves. And as we've just heard, creating software is kind of an intensely human endeavor. The human side gets easy to forget while we're deep in source code and build tools. I think it often takes a particular kind of personality to get deep into software. And sometimes that also takes forgetting about humans for a couple of hours, but they keep coming back. And this whole deal, like a conference, is also a very human endeavor, even though we talk a bit about software during it. So at a conference like this, you will see new things, and people will talk about a bunch of things that they have built, or things they think could be cool, or their experiments, their visions, their successes, and sometimes their failures. So during this conference, I've learned that I need to run a boat with nerves. I need to do stuff with Nerves Hub. I should not be afraid to use VOTP, which was not a way I've ever heard it stated before. I should not use OTP directly very much. I should not walk into traffic. Ideally, I should make it impossible to walk into traffic. I should leave tech, take my hacking into the real world, and produce small batch medication. I think that's the takeaway. And also, Zach had his big Ash 3.0 release, and I definitely want to try that. And Amos King told me he is particularly excited about the double entry part. That's an in-joke for like 5 people in the crowd. I'm terribly sorry. And thermostats are kind of complicated. There's a lot of people working on thermostats. What's up with that? So there's like talks. They're about novelty, they're about challenge, they're often about like hair-raising stories about important changes. At this conference, there's also a lot about people, which I think is a sign of a very good conference. But it is easy to feel like we should be doing the things that people talk about, and I think we should be a bit careful about that. Because most of the time, we don't give a conference talk about the simple things that just work well. Some people do, and that's something to encourage. And my hope is that during this talk I can give some ways to think about simplicity and some frame of reference for integrating tech tools and ideas and making systems that work, because maybe, just maybe, we shouldn't be bringing everything on board. Maybe all things, all ideas don't fit quite right together. So, show of hands. Who likes to keep things simple in their software projects? No? No? All right. And when you, hands up again. Well, if you look around, do you think you agree with the people that have their hands up about what simple means? Because there's going to be more about the hands, so get warmed up. Now, I need you to show your hands when I mention a term you find serves you in keeping things simple. So let's try a good start. Could be Elixir. A few. Phoenix. A few. LiveView. Yep, more. Postgres. Even more. Docker. Some. Make. Also a few. Serverless. Nice, Mike. Nice. I think it was just Mike Wad. Monoliths. Oh, a lot. System D. A few. Microservices. Damn, they've fallen off. There's like 2. Kubernetes. Kill it with fire. Terraform. Yeah, more Terraform. Object storage. Well, a few. For many of us, I think simple is about as easy to define as good. And that's the topic of today, simplicity. I don't think it matters what your domain or business is, and I don't think it matters what problems you're trying to solve. If you look close and pay attention, they are almost guaranteed to be complex. And if something seems simple to you, you might be on Hacker News, and you probably don't know it very well. If something is simple to you, you have probably internalized a lot of complexity about it, and probably just happen to know it very well. I think this also goes for a bunch of other problems, or since I'm a consultant, we call them solution spaces. The web is complex, databases are complex, file storage is complex, infrastructure is complex. And anyone telling you differently is selling you something. And ideally, they're also telling you about how they're making it simple for you. I think the devil is in the details of how simplicity is achieved, and it is our job as developers to contain, constrain, and manage complexity. Apparently also cultivate it. Thank you, Keithley. The goal shouldn't be to achieve complexity. It arrives on its own, piece by piece. It is not unique to software development. Any human endeavor seems like a constant campaign against just entropy. So, like, have you tried taking care of a house? Or a car? Or like doing gardening? Or maintaining a code base? Or like keeping a human body in shape so that it kind of works? So we willfully, and foolishly perhaps, impose a shape on the world, and then we strive to keep it from being compromised. We fight against decay. But all things decay at some rate, and it requires continuous effort to retain the integrity of our desired shape. And the more complex the shape, I think the more sensitive it is to entropy. This is the problem with node modules and NPM. It will require more maintenance and more operational effort to keep it intact. I think a respectable goal is to achieve your purpose or your solution in a way that is as simple as possible, ideally without doing anything, as Keithley kind of implied. And this brings us to Gall's law. A complex system that works is invariably found to have evolved from a simple system that worked. The inverse proposition also appears to be true. A complex system designed from scratch never works and cannot be made to work. You have to start over, beginning with a working simple system. I think this tells us more than just that simple systems are the way to go when creating new things. I think it also says that we should see the high value of existing complex systems that work, it kind of implies a lot of value in legacy systems and a lot about the danger of the big rewrite. So the software way to make things simple is typically abstraction. A higher level of abstraction should be simpler than the levels below it. Using it should produce more or better outcomes for about the same effort. And this should mean sacrificing something in translating the complex to something simpler. This description is, of course, a simplification, but let's not quite go recursive, because that's a very complicated conversation. But we can either place constraints on like the allowed solutions and restrict our future flexibility, or we can remove functionality, or we can make trade-offs in, say, performance, or correctness, or some other aspect. And I would call all of these opinionated approaches. Like an opinionated framework is something we often hear about. And if we try to solve web app development, and we have no opinion, and we accept no constraints, we want to be able to do everything, then we end up mapping the solution one-to-one. At best, because we can't screw it up. We can make it more complicated. So a one-to-one mapping is not like definitively evil. If you're implementing a spec in some language and it's like the library ends up as complicated as that's the spec, you might have done your job. But it doesn't constrain complexity. Well, Phoenix LiveView, as an example, is a highly opinionated approach to web application development with significant and clear trade-offs. It collapses a bunch of concerns into one solution. So the back-end logic, the API contract, the front-end API, and the DOM rendering all get collapsed. So if LiveView fits your needs, it removes a bunch of concerns. While Ecto is a little bit different in my eyes, the database library for Elixir, while it's kind of opinionated, and while it makes trade-offs in the service of like safety and ease of use and practicality, it is also closer to a one-to-one mapping. Ecto is not intended to constrain your options significantly compared to, say, SQL. And I think this is a thing with databases, by the way. They are the worst, and kind of the most important. They are where trade-offs matter the most, and I think that's also why they are the most common bottleneck, and it's because there are things we refuse to trade off about our data storage. I did not come to Elixir through Rails, but Rails is kind of part of Elixir's history, so I end up talking about it anyway. To my understanding, Rails is a web framework that was willing to trade off clarity and rigor for expressiveness and productivity. And it was built in a language that was willing to trade away performance for simplicity and a particular kind of elegance. And then Heroku came and offered something that fit with Rails. And the trade-offs made for Heroku didn't really constrain Rails at all, and it offered immense conveniences. So they were complementary and they were kind of harmonious, and you could shove a Rails-shaped piece in a Heroku-shaped slot without any friction and it would click right into place. Or that's what I hear. I didn't do any of this. And Rails became a darling of the startup world. And a startup is a very opinionated solution. You explore a domain with some disposable solutions, you create MVPs, you ship prototypes, and you try to find product market fit, and then you try to grow. So performance, rigor, and maintainability are not particularly on the list of startup priorities. There was no friction between the startup way and the Rails way. So supposedly that achieves this kind of respectable goal. The trade-offs are kind of well aligned, mostly stack up, and the Rails startup on Heroku achieves their solution in the simplest possible way without much friction or contradiction. Supposedly. Elsewhere, meanwhile, way earlier in Sweden, there was this wild software lab, and you've probably heard this story. They were creating a platform to operate telecom systems in a robust way. And the requirements included performance aspects such as low latency and concurrent operation. And then there were a bunch of things about operational aspects like deploying without downtime and a strong focus on reliability. It must not go down. This was a very different industry. Decidedly not a startup. I don't think people here know very much about Ericsson, but ask anyone in Sweden and they at least know of Ericsson. It is a large company, it builds a lot of infrastructure, and yeah, not a startup. It had different trade-offs to consider, and from this we got Erlang and OTP. I mean, the OTP. Ben can take it. He likes it when it's spicy. And no talk is complete without Dijkstra, and talking about simplicity and reliability kind of requires quoting, simplicity is a prerequisite for reliability. Erlang sacrifices some types of performance to get immutability, and immutability is a simpler view of the world. So we leverage the immutability to enable a set of simple building blocks. We get the process, we get send, we get receive, and this enables safe concurrency. And from this, we can build more and more abstractions in the service of getting our desired solution. And the result lives across like Erlang and OTP and the Beam virtual machine, and it is a very complex system. Someone mentioned trying to understand how the scheduler works. I think that was Sylvia. But it is a complex system that is proven to work and is clearly derived from simpler parts. And it made very different trade-offs from Ruby and from Rails. And it certainly made different trade-offs from what it was competing against at the time, which was C++. And I wish the story was that the world kind of realized that Heroku, Rails, and startups were a bit inefficient, and like we came together to push for more efficient use of our resources, and that's kind of why Rails is a bit less relevant now. But someone put JavaScript on a server and it ate Rails lunch. And Salesforce bought Heroku and left it to rot. So, as far as I know, startups are still a thing. It's off and on, and off and on. And like, check your interest rates in your local area, it might depend. But they still exist here and there. But I think they switched to focusing more on growth. And I believe the interest in like massive scalability and large engineering teams, which was connected to these massive unicorn valuations, changed technical priorities a bit. And this is probably a reason for them falling out of love with Rails and Heroku, because this is not where Rails or Heroku shine. And I think this is also where cloud native kind of gets rolling. So the trade-offs made for Ruby and for Rails had direct impact on performance and scalability, and Heroku was never the cheapest option. So at larger scale and with explosive growth, your priorities suddenly change, and the performance you traded off for your MVP becomes a factor that's strangling your progress. Like high cost at a great scale is very, very concerning to business, even if you have massive VC funding. When we talk about a good abstraction, it is always contextual to what you are currently doing. And maybe it should be contextual to what you're planning to be doing as well. The Rails and Heroku startup was very happy, and the hit company that's trying to scale on top of Heroku and Rails could be quite frustrated. It's a challenging thing. Now, if only someone would build us an ecosystem that was kind of about as productive as Rails, but scaled kind of differently. We can dream. But I think a good abstraction necessarily imposes constraints on you, and the best constraints to is to sacrifice things you don't want to be doing anyway. I don't even remember what I put on the slide. This is great. So a lot of Elixir devs find, for example, that immutability, as an example, makes their code easier to understand and easier to work with and follow. It reduces confusion, but it is a constraint, and it wasn't chosen initially because it made things easier to understand. It was a trade-off It sacrificed performance, but it made some really difficult things possible. We've lost the potential way to build things when we accept immutability. And we see giants like Google pushing towards HTTP3 to get away from the constraints of TCP. And you might be asking, like, I don't have any problems with TCP. What are they talking about? Because for the rest of us, those constraints have served us quite well. TCP gives us a bunch of reliability things, and we don't feel the pain of not getting enough throughput and not enough speed and massive data centers because we're not stressing TCP. Most of us are also not Google. And we want nice things. I'm certain we want nice things. I think we want all the nice things, so that's kind of where we get led astray. We want elastic scalability in our infrastructure, but we don't want to operate Kubernetes. And we want a horizontally scalable database, but nobody likes dealing with eventual consistency. And we want the speed of a cache, but we don't want to futz around with getting it right. And we want fantastic UI and UX capabilities, but we don't want a single-page app framework and all the complexity that can bring. We opt into any of these things, and we ought to opt into them with some consideration of the upside, like, is this important enough to make things more complicated? I think a mismatched stack of trade-offs removes all of your space to maneuver. I have seen people want to do Elixir, but write it like enterprise Java, and I think it removes all of your space to maneuver. You're taking the worst of both worlds. While aligned trade-offs feel like you're getting away with something, and I think that's what some people feel about LiveView. When it fits, it feels like you're getting away with something. It's kind of nice. We can only have everything if we have infinite time. And we're all very human, so what do you want to spend your time on? What feels important to control? What will you pay to ignore? What power will you give up for convenience? What capability do you give up for productivity? A project that will only run at massive scale maybe should start off with like the aspirational scale stuff like Bazel and Kubernetes from day one, assuming you can get to day 2 or 3, and I think John Gall has a law that says something about that. But if your project will never run at immense scale, maybe it's local, maybe it's small scale, then you can like trade off geo-distribution, you can trade off future scalability, and you can get a simpler system for that sacrifice. Erlang was built for industry. It traded off particular performance and strictness aspects in the service of building or getting this incredibly powerful runtime and building robust services specifically. It's a practical tool that doesn't try to be idealistically perfect. This is very annoying to some functional programmers and fine for others. Elixir is also an industry language. It doesn't pick a fight with any of the trade-offs that Erlang made. It invests in them to enable more in the realm of services. And Phoenix doubles down on that for web dev, and LiveView triples down on that for web app UI in my eyes. And at any point, one of us can feel that one of these constraints starts chafing. And I think that's the point at which our needs might diverge from the opinionated path we've taken. And this means it's on us to see if we can peel back a layer and accept more of the complexity or find another compatible approach with a better match in trade-offs, or maybe shift a trade-off or two around. Sometimes you can do that. Like a canonical case is probably Discord, who built their entire system in Elixir, and then it's like, this part really churns a lot. This part really hard to optimize. Okay, we bring in Rust, we make it mutable, and that solves that specific problem. And I talked to a bunch of companies that do Elixir. I would say 50-50 they do LiveView or they're doing a separate front-end single-page app. And the reasons are various. Some of it's historical, like LiveView is kind of young and it wasn't really ready when they took it on. Or they're doing a mobile app, or they have a front-end team that does want to keep their jobs and kind of argue. It's fair. I think if you take the constraints brought by LiveView, you'll find that there is a sweet spot for kind of a solo or small team building web-based SaaS. I think this is a mainstream part of kind of the Elixir offering. An Elixir developer can then thrive kind of end-to-end on that project and reap many of the intended benefits of those abstractions. And Bumblebee from NX kind of sneaks in and starts to expand that picture off into machine learning as well. And Phoenix is not heavy on opinions, at least not technically. We debate contexts as a design decision, and they're fundamentally very open-ended. They don't impose many constraints, and as such, they don't really deliver much guidance either. I've seen a fair number of developers point to this lack of opinion as a problem, like they want more of a Rails vibe or they want something else. Maybe they want event sourcing, some do. And to them, this is like a wide open space that should be filled with opinions to achieve further gains. And like, while other developers kind of appreciate the space to stretch their legs and do whatever they prefer. And some find context to be like enough conceptual guidance to just go off of. So I did actually, well, while preparing this, watch Keithley's talk from last year, and I've always appreciated his willingness to kind of collapse layers and just do the slightly unpopular thing and just write a bunch of code in a function. And some people love it, some people will hate it. It is an opinionated approach and a very active choice. And it's quite fun to actually meet the people you've had in your ears for many, many years. If you want more direction, you're willing to accept a lot of new opinion, and I think Josh would argue with me about this. He doesn't think Ash is very opinionated. I disagree. But you can add Ash framework to your stack, and it provides a bunch of constraints, a bunch of guidance, and a bunch of opinion. It will fill out everything between like Bandit and Ecto. And if you want that, it will bring you ideas on how like authentication, authorization, and tenancy can work. And Ash is interesting in this because you will find people that really dislike this approach. And they're really worried it's all Ruby on Rails and stuff again. And some people that are absolutely all in because they just want that direction. I think this indicates a framework that kind of puts forth a strong opinion. Some people disagree. And you want to make trade-offs that cost you as little as possible in a technical sense. And by technical, I mostly mean in a human sense, because depending on your team, you will find that some technical opinions and some constraints land very differently. To me, it seemed that generally developers with less experience benefit from the clarity and guidance of opinion. When you're still learning, making technical decisions is quite demanding and costly. Because you have a limited vantage point, you have limited experience to go off of, and then it's nice if someone else has sketched out a route. Meanwhile, more experienced developers tend to get really prissy about the specifics and may find it cumbersome that someone has decided how they should do things. And they want pointer and sharper knives to play with. And whether you should let your experienced developers go wild with sharp knives is up to you or up to your team, I guess. And I think this idea of low-cost trade-off is also what makes Fly kind of interesting in the Elixir community, and I think that's why it's popular. So if we already take on the trade-offs of LiveView and the general strengths of our platform, the Beam, we know that latency matters, and latency has always mattered everywhere. And the more we can cut down on latency, the better our chosen trade-off with LiveView specifically works. And Fly's whole vision is to put a web app closer to the user. But of course, putting the app close to the user is not enough, because your app is actually not that interesting. You usually also have data and files, and we tend to keep those separate. They're both data, I guess, but we tend to separate them. And today, most developers want a managed database and S3 compatible object storage, and these have become table stakes, and Fly has kind of not had a good answer there. So when S3 made object storage, It was kind of a prime example of a simple solution. It blew away some vast complexities that came before it. Who here has done NFS to share files between app servers so they could all have the same view of the world? Was it nice? Did it work well? I found it kind of horrifying. It was an absolute mess. It was terrible. And S3 gives a starkly limited API. It also used to be eventually consistent, but they've improved. But the starkly limited API lets the provider behind it scale essentially infinitely in terms of storage, which is difficult otherwise. And they can offer great reliability, which is difficult otherwise. And like really the only serious limitation about S3 in this circumstance is that it does not offer particularly great latency, and especially if you only store your files in US East 1. Did I mention I live in Europe? I use a lot of American software. So, do you take on the complexity of adding a CDN for your files just for my sake? Well, there's a few other people that live in Europe, but think of me. The people I work with at Tigris, they created the object storage solution that's on Fly now, and they are essentially collapsing the concerns of object storage and a CDN into one. So they make the assumption that you want both. And they offer geo-distribution by default, both on the upload and the download, which actually means you have a lower latency upload, which is kind of fun, especially with LiveView uploads. So that's their contribution to the vision. They're aligning with the Fly proposition. They offer this simple service that does a lot for you. The complexity is hidden behind like 18 years of progress since S3 launched, because it's been around for a bit now, as well as align trade-offs. Because I tried to push them on kind of, okay, but what's the trade-off you're making to get low latency object storage compared to S3? Like S3 can't just be dumb and just not have done it. And they were like, there's no real trade-off, it's just better. I'm like, I'm not sure I believe that. Can you unpack that a bit for me? Turns out, I could figure out why. They're selling you something. The fundamental selling point of cloud-based object storage is that you do not have to worry about disk space, and you do not have to worry about the reliability of your storage very much. So it's infinite storage, great reliability. Offering this requires taking on severe operational complexity. Basically, I don't want their job. And the work that Tigris did to achieve low latency centers around FoundationDB, which is a super cool, relatively recent database. It's younger than S3 at least, which is a very capable and very scalable database. And they use it for the metadata store. And most of the challenges about running FoundationDB are operational. So Tigris are just doubling down on operational complexity. And to them, I guess that feels like no trade-off, because they're watching servers all day anyway. They also do some software development, but I bet they watch servers most of the time. So to them, it's all the same, just keep it running well. So let's assume object storage for Fly is handled. The managed SQL database part on Fly is still unsolved. And Fly has clearly tried to solve this a few ways, indicating that yes, this is important to them. And Fly now has a managed database via Supabase. Super cool. That seems good. I don't know why it's not called Supafly. That seems like a miss. Possibly Fly-based, but I don't think that works. But the old Postgres offering was terrible, mostly terrible. So I think like Supabase is probably a really good improvement on that, but it is not a magical geo-replicated database. Supabase is not Postgres. It doesn't complete the vision. They're also trying some stuff with SQLite and LightFS. So Lightstream was not this. It was just streaming backup of SQLite. Don't get confused. LightFS, distributed, kind of weird. Yeah, I'm not convinced, but it's interesting. I like that they're trying. I've worked a bit with the folks that do electric SQL, and I think their approach has a lot of potential for this geo-distributed concept, because they're doing CRDTs for SQL. And CRDTs can be very powerful. You have to accept that it's eventually consistent. Otherwise, I don't think you get a horizontally scalable SQL database unless you go with eventually consistent. And Electric SQL recently launched like PG Lite, which is Postgres that's much more embeddable into your app. So we might see something interesting happen there. They have the eye of Supabase and they work with Neon, so like the Postgres folks are paying attention. So we might get Postgres on every server. I don't know. I've tried one thing with like SQLite on every server using the Electric SQL, like syncing backends and getting that all into a Postgres cloud thing. It seemed cool, but I haven't pushed it in any production settings. And why does it matter? Like if Fly and their partners pull this type of thing off. I think it makes for a very rare alignment of priorities and trade-offs from kind of end to end, like the platform, the runtime, the frameworks, and the language, all sharing values and kind of expressing an overall similar shape. I think it means that Elixir would be unconstrained by the platform it's on, while the platform also doesn't offer a bunch of complexity that is entirely irrelevant to an Elixir app. And this should give us trade-offs that cost as little as possible. You should be able to put a Phoenix-shaped app in a fly-shaped hole without friction and have it lock in nicely. And it should mean hilariously good latency for our users and customers. And I think that matters because the goalposts keep moving and minimum expectations keep going up, and what has worked up till here will struggle in the near future because that's the way it's kind of always been. I think it could be a true new Heroku, but for Phoenix, I don't think it's there yet, but I think it could be. And I will kind of leave the part about figuring out an opinionated business model that's entirely compatible to you all. Like, is it indie hacking? Is it open cooperatives? I don't know. But do give me suggestions. Like, or is it startups again? Does it have to be startups again? I'm not trying to sell Fly. I think they do that well enough, and I don't need to sell Tigris to you. I think they will prove themselves. But I think the overall idea has interesting implications for the mainstream web SaaS thing that many of us do. And many other applications will need entirely different infrastructure. Like I like working with nerves, and Fly doesn't really do it. Like I can't get my board up on there. So. And if you really want some beefy servers, like go to Hetzner and just get a bunch of cores and run Elixir on Metal. That's fun. And I'm personally always curious to like DIY anything and everything. I don't actually want to rent infrastructure. I want to build it. But that's on me. Like that's me desiring control and knowledge and thinking building things is fun. While in practice, I end up going with something more sensible and more pragmatic, and like, because at work, one of my constraints is I don't have eternity to build like a data center just because I feel like it. Instead, I have deadlines, and I pick something that makes sense for that particular situation, even when I don't want to. And the trade-offs of cloud services, any of them, AWS, Fly, Tigris, all of them, is to take operational complexity out of your hands for money. At least if they do it reasonably well. So they offer a constrained API, and then they leverage those constraints and the constraints that system places on you to achieve efficiencies in scale and manage the complexity for all of their customers all at once. And hopefully that's a complex system that works. And most of us are willing to pay some amount of money to remove operational complexity, but how much and in what way varies a lot. And it goes back just to managing complexity. Like demands on our software systems only increase, and as we build more and more software in response to those demands, we need to find ways to keep things manageable, keep things as simple as possible. And that's about raising the abstraction level of the work, or like reinvesting and keep reaping rewards from trade-offs we've already made. And thankfully, we don't strive to find all the appropriate trade-offs and figure out the practical constraints entirely on our own. There is community to be found in these opinionated choices. It seems that the more opinionated the technology, the tighter the community that forms around it. And then we get to push forward together by sharing and learning when we're doing this. There are no perfect technical solutions, and our preferred tools are not perfect. Other tools are not necessarily wrong, and every problem is too complex to be truly solved. And every solution is implemented by a nuanced mess of humans that are bound to screw it up somehow. And the computer doesn't care very much if you build something simple or something complex. So to me, simplicity is for people, and software is made by and for people. And we need to make technical decisions all the time, a lot of them. And technology that works for the majority of our needs is immensely beneficial because it reduces rote decision-making by a lot. It cuts away 80% of the calls you need to make, and we find other people with opinions worth trusting, and we delegate some of the research and some of the decision-making to each other, and suddenly we have a community. We're aligning on certain ideas. So I say we take our mostly great language and our rather solid frameworks and our promising platforms and our ambitious ideas, and we use them to build things that work kind of well for our tricky particular needs. And we can build it knowing that we have a community with us, that we overall agree with some of the time on several important technical priorities. And we're all a bunch of humans, somewhat aligned on software, all striving for simplicity, and I find that kind of neat. So thank you for having me.